Hari Om. In this session we consider energy stored in a capacitor or energy of a charged capacitor. Energy of the charged capacitor is measured by the total work done in charging the capacitor. Let us consider an uncharged capacitor and to be charged to a maximum charge of capital Q. Initial charge in the capacitor is 0 and at the instant during charging, let the charge is small q. This charge small q develops a potential difference small v between the plates. This potential difference is opposing the further charging on the capacitor. Therefore, the supply has to do an amount of work in putting an additional charge small q into the capacitor. So this small work done dW is equal to small v into dq, already studied. Therefore, to charge the capacitor to its maximum, that is capital Q, then the total work done W will be equal to integral dW, that is integral v into dq. So, the total work done W can be calculated as integral Q by C into dq from 0 charge to the maximum capital Q charge. Solving this integration, we get W equal to Q square by 2C. This work done is getting stored as electrostatic energy in the capacitor. So, energy stored in the capacitor, that is U, represented by U, that is equal to Q square by 2C. Now, this equation can be rewritten as half CV square or equal to half Q into V with the help of capacitor equation. Now, the same equation you can obtain from the graph given below. That is, this is the graph showing the charging of a capacitor. On x-axis there is charge marked and y-axis there is potential difference. So, as the charging is increasing, accordingly the potential difference between the plates is also increasing. Once the charging is maximum, that is getting capital Q charge, the potential difference between the plates becomes capital V. Now, here the work done in charging the capacitor is equal to area under the graph. That is area of the shaded portion, that is this part of the graph. That is equal to half into Q into V. So, energy is equal to half QV. Directly we can get. Now, let us go to another important result, that is energy density. Energy density means energy stored per volume of the capacitor. That is equal to half CV square by A into D. Taking C equal to epsilon 0 A by D, we get energy density equal to half into epsilon 0 into E square. From this equation, without doubt we can say the energy is stored in the capacitor. It is in the form of electric field between the plates. Understood? That's all. Thank you.